Hi everyone, I'm Junior Inko C, founder and inventor of the Vice Grid battery, which deals with renewables from power generation to storage systems. Today, our main focus is the Vice Grid battery, which can store energy efficiently, reaching up to 96% efficiency. Before we showcase the Vice Grid prototype, I would like to play a short video that explains gravity storage systems so that you can understand what they are.
Dropping bricks from a height can generate electricity. This is called gravity energy storage. When there is an abundance of electricity, multiple cranes stack bricks, like building blocks, to form a large open-air tower. During peak electricity demand, these bricks are allowed to fall using gravitational potential energy, which drives generators to produce electricity. Compared to pumped hydro storage, which requires specific geographical features, gravity energy storage is not location restricted. However, in severe thunderstorms and high winds, there is a risk of collapse. Fortunately, there are countless abandoned mines worldwide. Designing such a gravity device in a mine is much safer than an open-air tower. If there are no mines, hundreds of multi-layer shelving systems can be built to achieve the purpose of gravity energy storage. This gravity lamp works on the same principle. You just need to hang a weight next to the lamp. As it slowly descends, it pulls a string in the center of the lamp, activating a generator that produces enough electricity to light the lamp for.
Now that we all understand what are gravity storage systems, it's time to showcase the Vice Grid prototype.
Now that you've seen what the Vice Grid can do, I'm sure you've seen some LED illumination as proof that the system produces energy as the weight descends. Now it's time to pay full attention and focus, because this is the part where you understand what makes the Vice Grid efficient. We must carry the weight up, the very same weight which was creating energy while falling. This process is known as charging when it comes to gravity storage systems. But before we delve deep into this, let's start by showcasing the components one by one so you understand what's doing what when the machine is working. Okay, so we'll start with the cylinders. The cylinders are the heart of this project, as you can see that the two cylinders work like a ratchet mechanism. When we utilize a straight bar between the bigger and small cylinder, the two will rotate together, but when we press down the straight bar, the big cylinder on top will rotate while the small one inside remains still. Check the arrows. They are pointing at star-shaped paper designs to prove rotation movement. Then there is also an important component which I call the connector. That's because, as seen on the Vice Grid pics and videos, the triangular design tracks are designed to be separate, leaving empty space in between. And the connector is the only thing connected to both tracks by hooks, but when unhooked from the other side, the tracks are left with completely empty space in between. Check the arrow which is pointing at the connector. The main reason for this connector is to hold the rope when the round weight drops down on the second track beneath. But it does more than this, but we'll see it in action. Then the last component is the weight, which is round and big enough to roll smoothly on the two separate tracks. Check the arrow which is pointing at the weight. Okay, so now pay careful attention because we are about to get the machine into action. So now that you've seen it yourself, you can tell this is weird, right? But let me explain it in detail so we can all understand what's going on. As seen on the video, we start with unhooking the connector from one side, which makes some piece of the rope to be left completely loose and lying between the empty space. This happens because the weight descended in a triangular design system, which means the actual rope becomes longer when we unhook the connector because the rope is now in a straight form. Then we used an external source of energy on the small generator connected to the big cylinder by rope. But we press down the straight bar between the two cylinders before we start the small generator, and when we do, the small generator rotates, also rotating the big cylinder while the small one remains still. And while it does this, the big cylinder twists the loose rope around it. It does this until the only rope left is the one which is connected to the big weight. At this point, the small generator does not have enough power to carry on anymore. Then we utilize the straight bar, an external source of energy, to both the generators, big and small. Then the two generators, both big and small, will start rotating and rotate both the cylinders since we utilize the straight bar between them. Then you'll notice the big weight being lifted up until its starting point. Further evidence by creating a regular gravity storage system which is attached to something I call the tester. So for the tests, I'm going to use work to measure the output and input. You can research if you don't believe me. We can use work to measure energy, and that's what we are going to do. And to get a fair outcome, we are going to use the same weight. We'll just unhook them from one side to the other gravity storage system. So when we measure the output, we'll use a big weight on the gravity storage system and a small weight on the tester. So when the big weight on the gravity storage descends, the small yellow weight on the tester goes up. Then we measure the distance it went up. When we measure the input, we just use a vice versa process. We put the big weight on the tester and the small on the gravity storage system. The same applies on both systems to get a fair and precise outcome, as seen on the image paused on the video. You can tell that the cylinders on the regular gravity storage and tester are a little bit higher than that of the vice grid, but this has no effect since the vice grid's triangular design makes the weight to fall at the same distance as a regular gravity storage system despite being short. So let's play a video and see what.
Important note. Please concentrate on the arrows in the video, which are edited to showcase something important. You've seen it for yourselves that both systems have the same output energy, as you can see that the small yellow weight is in the same position and distance on both systems. Let's just pause it for a moment and remember, just concentrate on the yellow weight. As seen in the video, the blue weight on the vice grid can descend to a certain height but won't descend on the regular system. This is proof that the vice grid can use small amounts of energy for a certain height while the regular gravity storage system can't.